Here's another problem from the 9.1 Day 2 notes. It's asking us to find the different parts of this quadratic. So first off, our A is going to be -2, our B is 12, and our C is -7. All right, this opens down because the A term is negative. Then I'm going to skip down here and say that it has a maximum. All right, whenever the A is negative, it opens down and has a max. If it were to open up, it would have a minimum. The axis of symmetry, remember, is x equals -b over 2a. Okay, so for our problem, that's going to be -12 over 2 times -2, which is -12 over -4, which is 3. So if you look at the beginning, x equals all that, and then there's a 3, so I'm just going to say it's the line x equals 3. On the vertex, if I plug that into the original equation, I'm going to write the equation so I can scroll down. So it's 2x squared plus 12x minus 7. And anyway, I have to take and plug in 3 in for x here. So 2 times 3 squared plus 12 times 3 minus 7. All right, and that equals 11. But again, if you remember, that's y equals all this. So y equals 11, but that's not the vertex. The vertex is the point xy. So my x that I plugged in was 3, and the y that it spat out at me was 11. So the vertex is 3, 11. If I were to graph that on my graph over here, 3, 11, it's going to be way up, even off the graph a little bit. And that's okay, we'll come back to it. The other thing I want to do is put it in the middle of my table, 3, 11, right here. And then I want 2 numbers less than 3, so 3, 2, 1. 2 numbers greater than 3, 3, 4, 5. And we're going to plug those values in the calculator for x as well. So I have mine ready to go here. For 1, I got 3, and I plug in 2. Looks like I get 9. A lot of you have started to figure out the pattern that since this is in the middle of our vertex, the opposites, these ones are going to match up, and these, put a couple dots so they can see how they match up. Those are going to match up. So we have 9 and 3. So if I go 1 to the side of my vertex 3 here, this was at 9 for both of those, and then at 3 for one more back, for 1 and for 5. So if I connect, I'm not doing very good, but if I connect the dots, the parabola opens down, and it's pretty skinny like that. Okay, we don't have to worry about this value part. The Y-intercept, that's when we plug in 0 for y. So if you have that in the calculator that you just used to fill out your table over here, you can plug in a 0 for your x values. And I got -7. So 0, -7. Again, when the x is 0, it's whatever the y value is. And that's our y-intercept. The domain is always -infinity to infinity with quadratics. And then the range, ours, if you remember, starts at -infinity. It's wherever the lowest one is. So the highest value is 11, and 11 is included. So I'm going to say -infinity with the parentheses, and since the 11 is included in the answer, it gets a bracket. And that's how you do a few more quadratic problems.